Okay, so my name is Jabbar, and I came from Dave's YouTube. I came from Tyler's YouTube channel where I found Dave, and I was really intrigued about how he thought the Earth was flat, and some of his, um, let's just say, like the way that he answered his questions, because it was honestly eye-opening, and I had a few questions of my own.
Have you ever considered the idea of flat Earth before you saw Tyler's video?
I'm of the mindset, never believe anything you hear or say. I've always been of that mindset. So I don't disapprove of it because I can't.
But had you ever heard of it before?
Flat Earth?
Yeah.
Oh, definitely.
Okay. So you heard of it, you never looked into it, you saw me on Tyler's, and now you want to know why I think the Earth is flat.
Yes.
So let me ask you a question. When you go outside on a quiet day and sit down, do you feel like you're spinning?
No.
You feel like you're moving in four different directions at once at incomprehensible speeds?
No.
You ever watch the sunset?
Yeah.
So, do you think that what do you see? Forget what you think, what you've been told. What do you see? You see the sun just going away, right? But in the heliocentric model, you're told that you're falling over backwards faster than the speed of sound. Do you sense that at all?
No.
So, did you take science? Can I ask how old you are?
Oh, I'm only 23, actually.
Well, oh, that's Tyler's 23 also. So there you go. So you went to high school,
Yes, sir.
take science class.
Yes, sir.
So when you have gas, air, any kind of gas, what does the gas want to do? It wants to equalize, right? It wants to equalize, right? When you
Yes,
open up
sir.
a soda can, what does it do? Psst, what's that? It's equalizing to the air around it. The pressure in the can instantly equalizes. Okay.
Yes, sir.
So in the heliocentric model, we're on a rock, lumpy rock, surrounded by curved water, spinning. The water ignores the centrifugal force of the spin for some reason. Air is around that, and it's adjacent to the biggest void of pressure known to mankind that we can't even recreate here on Earth. Why doesn't the air violently fill the outer space?
That's a good question.
There's only one answer that they come up with, and it's a horrible answer. It's gravity. Gravity has to be holding the air down, right? But a summer breeze can blow left, it could blow right, up, and down, but somehow gravity is supposedly holding the air down, right? So imagine I had a lucite, a glass box, and we sucked all of the air out of it. So we have a void, a vacuum, no pressure. And I had a little valve on the bottom of the box. If I open that valve, what's going to happen?
Air will come out.
No, there was no air in there. There's no air,
Okay.
so it's gonna suck it. Whether it's
Yeah.
sucking or the air is pushing its way in, doesn't matter. It's going to equalize. The air in the room will
Yeah.
equalize. And
Exactly.
if I turned it upside down, would it still do the same thing?
Yes.
Sideways,
Yep.
out of 10,000 feet in the air, would it do the same thing?
Yes.
Okay. And they say in the heliocentric model that gravity is strongest closest to Earth. So standing on the ground has more gravity than 100,000 feet or higher. It has a little more gravity. So how can that void, that vacuum, that empty box fill with air, pulling it or having it pushed up and away from gravity? Doesn't make any sense, right?
Not really. No.
Hey, you were never taught this. Ignore the autofocus. Um, so nowhere ever in a lab in in nature has man been able to create high pressure next to low pressure without it trying to equalize, without having a physical container, right? You tried to, if I said, hey, let's have a barbecue, go get some propane, but don't bring the tank, just bring the propane. Can't do it. Propane is going to
Hmm.
just disperse and equalize into the air. It's all gone. So, how do we live on a ball adjacent to a space void, right? Gas always wants to fill the available space, right? When you blow up a balloon, there's pressure. It's more pressure in the balloon, so it's than the air around it, so it stretches. And if I push that balloon underwater, it might shrink a little bit. It will shrink a little bit because of the pressure of the water is stronger than the air pressure, but the air still wants to get out, right?
Yes,
So
of course.
they tell us that our sun is made up of gases. So every experiment that we can do in natural science using the physics of gases, gases violently fill the available space, except in space, where there's so much gas that it decides to collapse on itself and create a liquid sun burning in a vacuum. Okay. This is bizarre, isn't it? And they tell us how old is our sun, you know? They tell us it's billions of years old, 6 billion years old, whatever
Yeah.
it is. Okay, some ridiculous number, right? You can't even fathom what that is. And they tell us that it's burning, and I forget the number, but it's so ridiculous it doesn't matter. It's like 600 billion tons per day or per hour or something. It doesn't matter. It's a huge amount of fuel that is being burned, consumed every single day. So 600 billion tons a day, whatever the number is, even if it's 6 billion tons a day, over billions of years, do you think that the sun would start shrinking and running out of fuel eventually? Oh, it's so big, you wouldn't notice that. The gravity never changes. The sun, made out of helium and hydrogen that defy gravity, somehow have enough gravity to hold on to the Earth and Saturn and Pluto and ignore all the moons. It just holds on to the planets and they work in perfect synchronicity. Does that make any sense to you?
When you put it like that, no, not
Right.
at
You sound like a really smart kid. You really do. I talked to a couple kids recently, and I'm impressed. You're thinking. You have God given common sense, and you're actually using it. Okay, this is fantastic.
Yeah.
Okay, so on the flat Earth, we're crazy. We're absolutely crazy because we think down is down for everybody. We think down is down for everybody. The physics of water at rest lays flat, right? All plumb bobs are parallel to each other. They're not opposed to each other, but on a globe Earth, they want to tell you this is normal and we're crazy. That this guy's down is this way and this guy's down is inward and this guy's down. Down is down. We're on a spinning ball. It seems a little absurd, doesn't it? But gravity. Do you know that gravity is just a theory? You know that? They've never proven gravity. It's such a bad
They've
theory.
never proved it.
They've never proven it. Look it up. Neil deGrasse Tyson, the high priest of scientism, says, what is gravity? He goes, we don't know what it is. But when we measured all the gravity in the universe, we're missing some. 96% of our equation was wrong. 96%. Okay. So they made up, no one's ever seen it, no one's ever measured it, no one's ever experienced it, dark matter and dark energy. Do you know why they made it up? Because without it, gravity doesn't work. Therefore, it has to exist. Okay? Does that make
Okay.
any sense to you? It shouldn't.
No, it doesn't.
It-
That doesn't make any sense at all.
right. So
So
when you have a
my
theory that's
question,
90, hold on. When you have a theory that's 96% wrong, do you try to fix it or do you throw it out and try to come up with another theory?
I would probably throw it out.
Okay. What's your
I
question?
would throw it out. So my question is, all right, if let's just say they lied about gravity and things like that. they lie about everything. But let's just say that gravity is another thing that they lie about. Then what is it? Is it just energy then? Or
Great question.
what?
So, in the flat Earth community, we all are discussing the possibilities of gravity, and we're in kind of two camps. Okay. And both camps agree on something completely. The second camp, which I'm in, we think there's something else. Okay. But we all know that a gravitational ball can't, doesn't work. Yeah. Have you heard about the three body problem?
The three body
Yeah, let me tell you, it's
problem.
okay. You probably never heard any of this because they're not going to teach any of it in school. So, and I'm going to answer what gravity is. So, we can get a computer model and say, all right, we got a sun, it's got this much mass and gravity, and we have an Earth, it's got this much mass and gravity, and we could set them into motion in the computer simulation, and it works perfectly. It can predict where it's going to be anytime in the future exactly. Then you throw in a third body, either another planet or a moon, so they're all orbiting around each other, and something crazy happens. It goes into now these are three bodies the same size. Look, they start out, oh, this is nice, but their gravities perturb each other. And then it goes into what I call chaos mode. And no supercomputer in the world can figure out what it's going to do next. Our best computers can't tell you where this green ball is going to go next. And this is just three bodies with the same mass. Okay. So our solar system has, I don't know, 100 and some odd bodies. Our galaxy, right? But somehow everything remains in perfect order, right? So this gravitational model is complete and total absolute nonsense. So what is gravity? What is gravity? So we live in an electrical realm. Everything is electric, from your body to the apple that you ate to the rock on the ground, the tree, the grass. Everything, not a theory, has an electrostatic charge, period. The ground,
Yeah, everything is energy.
everything is energy. So the ground has a neutral or negative charge. That's a
Yeah.
measured fact. Anything above the ground has a positive charge. Now, before we get into charges, why does this ball fall down? And the answer that we all agree on is it's more dense than the air around it. If I dropped it on a swimming pool and here's the surface of the water, it would sit on top of the water because it's less dense than the water. And if I dropped this in rocks, the rocks would go through the water. This would sit on top of the water. And I let a helium balloon go, it would go up because buoyancy and density sort everything out. You with me?
Yep.
So here's a balloon.
Hmm.
And it's just not blown up. And I'm just holding it and it's drooping down. Why is it drooping down? According to what I just said. Answer is because it's more dense than the air around it. So it's just hanging. With me?
Okay. Yep.
So now I put some air in it. Now it's stretching. What's that air trying to do? It's trying to get out in every direction, including up. That air
Yep.
is strong enough to stretch this balloon, right?
Hmm.
If I could turn a dial and make gravity 100 times stronger than it is right now, you think that balloon would get pulled on a little bit by the gravity? Probably.
Yeah.
Right. So I would need to increase the gravity just to stretch this balloon a little bit. But when we look at this balloon with air in it, the air is strong enough to stretch the balloon. How the hell can gravity hold on to air when the air is stronger than gravity? The air's desire, if it has a desire, the air is trying to, the gas, excuse me, is trying to fill the available space, trying to equalize. With me?
Yep.
So let's get into, so the obvious question is, when I drop this ball, why doesn't it go that way or that way or that way, right? And the answer that some people like to give is that's just the way it is. I don't like that answer because this is something we can never test. But let's say I snap my fingers and the entire Earth disappeared. If I drop the ball, which way is it going to go? Which way is down? Right? There's nothing there. Now, a lot of people get upset at this analogy because that's like talking about crazy land, right? But why doesn't it go down? Well, we're talking about the static charge, and there is I said the Earth is neutral or negative, and there is a measurable downward flow of electricity from the sky to the ground. If you have a drone, get a thin copper wire, a long piece, fly the drone up, and then touch that wire, and you'll get electrocuted.
Hmm.
Because every meter, I think, is another 100 volts of energy in the air.
Yeah.
So, so they don't want you to know that. So how can we test this? Right? Here's buoyancy and density. Excuse me. All right. Blimp is less buoyant than the air. Ship is more buoyant than the water. Submarine, less buoyant. Right.
Yep.
So here is we got some helium balloons. We're tied to this. I have a button right here, and it's a couple inches off excuse me, I'm dying. Fourth interview today. Excuse me. And we're going to add a positive charge. And as we add it, it goes down. Are we manipulating gravity or the electrostatic potential? We made this heavier because it's electrostatic charge. It became more positive. When we discharge it, it goes up, right? And then
Uh-huh.
this is one where we put a negative charge into this and it goes up. Are we defying gravity or are we defying electrostatics?
You're defining electrostatic.
Right, because we're not adding weight to it. We're just changing its charge. If you look at the periodic table, each element that's heavier than the next one has one more positive charge to it. So the higher the positive charge, the more attracted it is to the ground, and buoyancy and density sort everything else out. It just says down is this way, right? Now,
Mhm.
science does not deny the electrostatic charge. They know it's real, right? It's here. Matter of fact, MIT created the silent drone, and it has no moving parts and it flies. It just has a negative charge to it that it can maintain, and it rises up from the earth. Doesn't make any noise. No moving
Mhm.
parts. It flies. Is it defying gravity or is it using electrostatics? Well, we know the answer. Okay. So mainstream science says that the electrostatic charge is 10 to the 26 power stronger than gravity. So you know what that means? It means you can't fathom what that number is, because a trillion, trillion is 10 to the 12th, right? And you can't fathom what a trillion is. Let me ask you a question. I'll give you a Bitcoin if you can guess it within 2 hours. How long is 1 trillion seconds?
How long is one true
You can't
second?
type that in. There's no Googling.
Oh, I'm not typing
How
anything.
long? Just take a guess. 1 trillion seconds.
I was just repeating it back in my head.
Yeah. Just
Um,
take a stab in the dark. You won't get it.
I have no idea,
Take a guess.
actually. Mm, Like 5, will it turn into like minutes or something?
Well, how long
Or,
is one? You can measure it in days. How's that? Or hours,
okay.
or years. Measure it in years. I'll give you a hint. Measure it in years. How long is
Uh,
1 trillion seconds? Just take a guess, because this is to demonstrate how big these numbers are.
so that would probably be like, I'm gonna say 200 years.
Very close. 31,000 years. Okay. 31,000 years. 1 trillion seconds is 31,000 years. You weren't very close. 31,000 years. Okay. So,
Okay.
so they say that the electrostatic force that I just demonstrated is 10 to the 26 power. If it was 10 to the 12th power, that's 36. That number is a trillion. Okay. It's way beyond that. So basically, what they're saying is if it was gravity that made things go down, if I had a 50-pound dumbbell plate, whatever, and I let it go, I think it would float forever because that force is so weak it wouldn't be able to move it to the ground. But I mean, it's so insignificant. So they're kind of telling us the truth. Gravity is so small, it doesn't exist. 10 to the 36 is a number that 26, you can't comprehend it because people can't even comprehend what a trillion is.
Yeah.
So I demonstrated how things can go up and down. Buoyancy and density, obvious. That's true even with gravity. But what is causing it to go down? Are you still there?
Yeah. Can you hear me?
Yeah, yeah. Something my OBS just quit for some reason. Um, where'd it go? Okay, there we go. So there you go. I mean, let's say gravity existed and the electrostatic force existed. When I drop something, well, 10 to the 36 power is stronger than the gravity force. What's making it go down? Obviously, it's the electrostatic force. They're telling us the truth. That's something Tyler couldn't comprehend, and he cut out a lot when we really explained it to him. This, you know what? I have to commend you for reaching out to me and having this conversation, Jabbar, because you're using your God-given common sense. You can believe anything, right? I told you did I tell you where I live? I live in Connecticut. Okay.
Yeah.
Is that a belief from by you, or do you know it?
That's what that's you know it.
Where do I no, I know where I live.
Yeah.
You know where I live.
Yeah.
Do you know it or do you
Yeah.
believe it?
You know it.
No, you don't know it because have you verified that I live in Connecticut? What if I lived in California and I'm telling you I live in Connecticut? So you're trusting me and you're believing me.
Or
Why would I lie about that, right?
yeah.
So you have to ask yourself, why would teachers lie? Well, I don't think teachers are lying. I think
It's not.
they're just lost. They're just memorizers and regurgitators. Okay.
Well, that's what school is. It's all a repetitive. Uh, that's a whole nother rabbit hole. But
Now
that's literally what school is to create factory workers.
you
It's
are
not.
you are getting it. Are you going to college? Please say no.
No, no.
Oh, God
I
bless
don't
you. God bless you.
want to
Even if you
learn
had a free ride to college, the only reason to go there is to go hang with other people and make good friends. That's the only reason. That's it.
to network. That's the only
That-
reason
That's
I
the
would
only
be
reason.
to college.
100%. 100%. You got to follow your passion. And with today, with the internet, with everything, you can do whatever you want. If you go to college, college is a trap of indoctrination, financial hardship,
The rabbit hole.
complete and total nonsense. All right. So eventually, when you're done asking me questions, I'm going to ask you questions. Why do you think you live on a globe?
Okay. And so my other question is, all right, so explain like daylight savings time then.
Daylight savings time. So if you were well, they say it's for farmers and everything, but if you had a blanket that your bed blanket it only came up to here and you were cold, could you cut off a foot of it at the bottom and sew it to the top so it comes up higher? Ridiculous, right?
Yes.
It's ridiculous. So they moving the daylight savings time. They do that because we as humans are tied to the movements of the sun. We're tied
Yes.
to all of this, and they're just doing it to throw our body clocks off. They're doing it to keep us out of kilter, right? The
Okay.
days are shorter in the winter because the sun is farther away. What you're in are you in New Jersey? Where did you say you were?
I'm in PA.
You're in PA, that's right. So the days are shorter because the sun is farther away. If you go out on a street that has street lights, a long straight street, the one above you, the street lights right above you, we'll call that your summer tropical sun. It's directly above you. You look
Okay.
down the road, those lights that are at the same height, they look like they're at your eye level. And a mile down, you can't even see those lights anymore because everything merges into the horizon. Okay? Everything merges into the horizon. Let me show you how that works. Okay.
Mhm.
And so, because a big question you're going to have, I know it is, what about sunsets? How does that work? Right. So,
Yeah,
yeah.
exactly.
So here is a you're looking up at this building, and the sun is just moving throughout the day, and it's going beyond the building. Okay, you're looking straight up at this building, right?
Mhm.
So is that sun below the horizon or is it just beyond the building?
It's just beyond the
Very good.
building.
If you wanted to see that sun again, what could you do?
Move.
Besides move to the side, you could go up. Let's say you had a balloon and you could fly up. You can look over the building and see the sun, right?
Yeah.
Okay. And hold on a second. So, or you can go backwards. What if there's just farmland fields behind you? You can go backwards until that building gets small enough and you get a better perspective and you can see over the building, right?
Mm-hmm.
So here's how we see. Everything goes to the vanishing point. The sky and the ground, the sides go in. So I'm gonna pop a guy in here, and his eye line is right here. And I'm gonna pop this mountain in here. This mountain is thousands of feet over his eyes, over his head. Agreed?
Yeah.
Okay. And the sun is above the mountain. Now I'm just gonna move the sun away, and perspective makes you think it's going down. Now that sun is below the horizon or just beyond the mountain.
Just beyond the mountain.
You're getting all of these right. So many adults and kids cannot answer these questions correctly, right? You are going to have a very successful life, right? So how could he see the sun again? He could fly up in the air, or he can go backwards across the farmlands a couple miles, and then that mountain would be lower. So let's move him backwards, right? And then he'll see the ground like this, and he can see the sun again, because this mountaintop right here, is it in reality at his eye level, or is it thousands of feet above his eyes?
It's 1,000
It,
feet above his
it's
eyes.
thousands of feet above his eyes, but the way we see with perspective, it looks like it's at his eye level. Now let's move the sun farther away again. The sun just went beyond that mountain. Now we're going to add the clouds in. These clouds are also going towards the horizontal eye zone. They're all getting compressed right here. So here's the sun, and the sun goes
Mm-hmm.
away. And now this mountain, thousands of feet above his eye level, these clouds that look like they're at the same point as the mountain are thousands of feet above the mountain, and the sun has just gone beyond it. And you can't see it due to perspective. Get it?
Yeah. I mean, that would make sense.
It does make sense. All right. What else?
So, how about time zones then? Because
Time.
if you live in California, it's 4 o'clock, but here it's 10 o'clock.
100%. You're absolutely right. So, did you know that in the north there's 32 time zones, and in the south, no, in the north there's 18 time zones. In the south there's like 32 time zones. Weird,
Yeah,
weird, right? So here, well, you know what?
yeah,
I'll show you an easy way to visualize this. Okay, so we're looking down at the Earth. This is my app. Okay,
yeah.
and each one of these hours is a time zone. Okay, let me turn on the time zones actually. So there are the time zones. Okay, and wherever the sun is, it's noon. Okay, wherever the sun is. So I'll turn on the time zones. So it's early morning in Australia, and it's late night over here on the East Coast. And as the sun goes around, wherever it is, it's noon, and here are all the other time zones. The sun is a small local light, just as we experience it within the Earth system, and it just circles around the Earth and takes its light with it. And when the sun
Hmm.
is, so if we had a, if you, let's talk about um, seasons, summer. So if you're trying to stay warm and you have a heat source, the closer you are to it, the warmer you get, right?
Yep,
And if you're far away, it's cold, right?
yep.
They tell us that in our winter, the sun is 3.5 million miles closer than in our summer in the north, right? So if you and I were sitting outside in a Pennsylvania field, we're 25 feet apart, it's super freezing, it's February, okay? And then somebody comes and has a 15-foot high pole and they're holding a big, strong heat lamp directly over you. You're going to go, that feels great. That heat's going to radiate down on you. And I'm going to be far away and I'm not barely going to feel that heat at all. And I'm going to say, where do you see that sun? And you're going to go, it's right above there, right? That's your sun. And I'm going to say, well, I don't see it straight up. I see it over there. It's much lower in the sky for me, even though it's still 15 feet above the field that we're sitting on, right? And that person walks over to me, keeping it at the exact same height. I watch it get higher and higher and higher and higher and higher until it's over me. I'm warm. You're cold. You see it low in the sky. I see it directly above me. That's how seasons work. Okay. So let me show you. Let me show you here. Let's turn this off. So this yellow line is the Tropic of Cancer. You've heard that before. This is the Tropic of Capricorn, and the equator is halfway in between. So we're in October. So I go November, December. In December, the sun is all the way out here. It's summertime in December in Australia. That's when they have their summer.
Yep.
Africa, summer, right? South America, summer, right? New York, Pennsylvania, winter, cold. It's far away. Sun's far away, and therefore it rises later. It comes close enough to be in view later and far enough earlier. So we have a short day, and it never gets that high in the sky. 6 months later, the sun moves all the way up here. It's higher because it's like the streetlights, closer, higher, warmer. We have our summer. They have their winter. That makes sense. Okay. That makes sense.
Yeah, that makes sense.
Yes. All right. So that's how time zones work. Okay. Wherever the sun is, it's noon here. It's midnight here. It's 6 a.m. here. Okay. So when the sun is over noon in South Africa, it's 6 a.m. in Pennsylvania. Right? The light's coming around, right? 6 a.m. Sun's just starting to get close enough to see it. It comes around, it comes high. And if I moved it back out here to the Tropic of Capricorn, it would be lower in your sky. It'd be farther away, like that street light down the road. Just like it is in the winter.
Okay. But wouldn't that, but how would that happen on a flat Earth though?
Why
Because doesn't,
why does the sun migrate in and out?
yeah.
Great question. It's the way this world was made. We don't know what causes it to go in, but we believe that we live in you know what a toroidal field is?
I've heard of it, but I don't really know what it is.
Everything is a toroidal field. Our hearts are toroidal fields. They come out, around, and they come back up again. You know, an apple, toroidal field. The earth is a toroidal field. And if you Google it, you'll see that there's a plane of inertia inside the toroidal field. That's where we live. We live on that plane of inertia in this electrical system. We can't live anywhere else.
Okay.
And here's the thing. Here's the thing. We don't have all the answers. But one thing we know for sure, this place is intelligently designed. It didn't come from a Jesuit priest who made up the Big Bang and said, oh, that happened and then lightning struck and nothing turned into everything. And then an amoeba turned into a fish that grew legs and climbed out of the water, found another sexy legged fish and turned into a monkey. Then it had a mutant baby that turned into a human. Okay. That's what they want you to believe. The truth is we were created. Now, where you go with that, you got to figure that out yourself. That's a life journey.
Yeah, that's could be anything. Interesting.
What else you got? You got more? You have to have more questions.
I have one. Because I don't have a lot of questions because a lot of questions you answered on Tyler's video, actually. So the last question that I had was, how about a lunar eclipse then? Because how about that?
Yeah. So let's talk about eclipses. That's a good one. So A lunar eclipse is when, right? When the Earth gets in between the sun and the moon and casts a shadow on the moon.
Yeah.
That's what they tell us. Okay. So I want you to tomorrow, when the sun comes out, when it's high in the sky, put a basketball on the ground and look at the shadow on the ground. Nice, crisp shadow, nice circular, crisp shadow. Then lift that
Oh,
basketball up as high as you can hold it and look on the ground for the shadow. You won't even see it. Shadows disperse. They bleed over distance. How do you cast a perfect shadow on the rock a quarter of a million miles away? Cannot be done. It cannot be done. That's problem number one. Problem number two is if you're standing here, you're always on the top of the globe from your point of view. And to your right, you can see the sun above your horizon. To the left, you can see the sun above the moon above your horizon. Could the eclipse start? They're not in line.
it
They're not in line yet.
it could. No,
It can't
it
until
could.
one of them dips down below the horizon. So watch.
Yeah.
As I move the earth up, right, it gets in line and there comes the shadow. Okay. And this is
Yeah.
supposedly what happens, right? This so there's been over 50 selenilian eclipses. That is when the eclipse starts before the sun or the moon is below the observer's horizon. And the other thing is, the last selenilian, the shadow came in from the top. Wait a minute, Earth is down here. How does the shadow come in from the top? Right? And you know what the scientists call that type of an eclipse? They have another name other than selenilian. They call
What?
it the impossible eclipse.
Nothing's impossible.
Well, they say, well, that this is science for you. It's like dark energy for the gravity, dark matter. They're like, it's impossible, but it has to be possible because it happened because we know that the Earth causes the shadow on the moon. The Earth does not cause a shadow on the moon. Now, we can completely falsify the Earth causing the shadow on the moon. Falsification is independent of replacement. Okay, it would be nice if we knew. We have theories. Um, but I don't believe that the moon or the sun that we see is a physical object at all. Because when there's a new moon, you don't see anything. Okay? You don't see the no one when the moon goes new, I think it's 42 hours or 60 hours. It's over 2 hours, it's over 2 days that nobody from anywhere, from space station, which is not real, airplanes, infrared lenses, mega telescopes, has ever spotted the moon during that 42 hours or whatever it is. Okay. No one, wait a minute. If during a solar eclipse, why don't we see the moon? Because the earth shine, because if you're on the moon, you'd see a full earth. That earth shine should be more powerful than moonshine, and moonshine casts a shadow on the ground. How come we don't see the moon? And I believe because it's not there. Okay. It's not there. So here is a solar eclipse. Do you see the moon? Are you there? Did I lose you? Are you muted? Did your microphone come undone?
Can you?
Oh, now I hear you. What happened?
It. Sorry about that.
It's all right.
My that just happens sometimes, but
It's okay.
no.
So you see missing sun. You're getting all this crap right. Missing sun. You don't see the moon. You don't see the moon.
Yeah.
You don't see the moon in any of these. You just see missing sun. Missing sun. Right? It's missing
Mm-hmm.
sun. So what is it? I kind of think, and this is just me, that the sun that we see is being projected into our dome of vision. I call it our azimuthal grid of vision or our personal atmospheric dome. Right? Let me show you real quick what I think. And this is interesting, right? So this is real quick. This is an eclipse I filmed. This is a rear projection onto a paper towel. So the sky is our screen, and this is now a real eclipse. It's like 85, 90%. And we see this and this. This is a lens flare because it's moving around, but this one is locked into position with the sun. What is that? And I theorized maybe this is the real sun that's behind our sky that we never see except during an eclipse where we can see because there's not that much sun blinding us. So here is, let me just jump forward. So here we have my paper towel eclipse going. You don't see the moon, right? Because this is how it is. Here's the source light being projected onto the sky. And you don't see the moon because there's no light on it as it comes in and creates this eclipse. But then I said, and you don't see it leaving, just like we don't see the moon leaving. So this is exactly how we see an eclipse. But I said, what if the sky is a little more transparent? So I got I got tissue paper, and I did the same thing again. Here it comes in. And this is the projector, the rear projection. Okay? There's the rear projection. And when we compare it to what we saw in reality, do you see any similarity?
Yeah,
It's
a
exactly the
little.
same. Here is the sun
Yeah.
that we see. Here is this weird thing. This is the rear projection. This is the source of this light. This is the projector behind the sky. The paper towel, the tissue is the sky. And this is what we're seeing. That works perfectly with what we see. Now, hey, maybe there's a better explanation, but that works. And when you understand cosmology, where we live and there's a dome above us. Now, if you look, you can look at it biblically or you can look at it scientifically. There was a thing called Project Fishbowl where they were shooting bombs up at the sky, exploding them, trying to see what's up there. And the bombs, when they exploded, this was in the 1950s, I think, they exploded. You could see that they were hitting something and spreading out. They were trying to blow a hole in the dome, in the firmament.
Yeah, they hit the. I saw that video.
All right, you've seen it. Very good. You're actually looking around. This is fantastic. Um, and so maybe that's what's going on. But here's the thing: we don't need to look up into the sky or beyond the shoreline of Antarctica to prove that we live on a flat, level, stationary Earth. Okay, there we can measure, right? Perspective shows us that that the higher we are, the farther we can see. Okay.
Mhm.
Let me show you. That's not what I want to show you. Where is it? The higher we are, the farther we can see. Where is it? Oh, here we go. Okay. So here's a viewer, and he can see this is his horizon here, this red line, right? But as we move him up, he can now see farther than this red line. His horizon's farther. So the big argument people say is, the Earth is round because you can watch the sunset here in Dubai and then go to the top of this tallest building in the world and you can see the sunset again. That's because you can see farther. You can see over that mountain a little bit. You have a better angle. Even if there's no mountain, if there's just water, the air becomes opaque over distance. Like if you were in an Olympic-sized swimming pool, you can't see the far side of that swimming pool because the water becomes opaque, right? Let me show you what I mean. Do you see me? Yeah. But if I turn off all the lights in the room, would you see me?
No.
Right. So you see the light that's bouncing off of me.
Yes.
Right. Now, no one has gotten this question right because it's just a weird question. What's brighter, the light that's bouncing off of me or the actual light itself?
The light that's bouncing off of you?
Well, what is brighter if you took a light meter to the light that I'm looking at over here or
Okay.
light meter to my face? Which one is going to have more light, brighter light?
The light
The light
that,
itself. The light
yeah,
itself. Because that's the source. It's bouncing off, everything's spreading out. You're losing light. Okay. Now, if I had a mirror, it might probably be exactly the same, but I'm not a mirror. Okay. So
yeah.
here we have, this is a spot in the Illusion, France. We're looking out over the water. Globers say this is the curve of the Earth. And there's a mountain called Mount Canigou, 175 miles away. According to Globe Math, from this viewing height, the top of Mount Canigou should be well over a half a mile, closer to a mile below the curve of the Earth. And guess what? You can't see it. Therefore, the Earth is a globe, right? But if it was nighttime, you couldn't see it. But during the daytime, the light that's bouncing off of Mount Canigou is not strong enough to push through 175 miles of thick atmosphere. However, the sun, the brightest object in the world, is bright enough to push. And as the sun goes away, it starts backlighting Mount Canigou. And here it is in its entirety, right there where the mouse is. That's the top. That top should be almost a mile below the curve of the Earth, but it's right here. You know what the globe argument for this is? Oh, the sun already set. Mount Canigou is that far below the horizon, and it's magically refracting up and stopping at your eye level. That's the official explanation for this.
That's funny.
It's stupid.
That's why it's funny, because it's really stupid.
God, you know, if I ever come to Pennsylvania, I'm going to reach out and take you out to lunch or something. All right, you give me hope for the future, because there's so many stupid people in this world.
So many.
So many. Right. Right. What kind of phone do you have?
I have an Android.
An Android. When we're done, I'm going to give you a free download code and a lifetime free subscription to my app so you can find more information and research this stuff and make up your own mind and learn how to do the experiments that we already did. Okay?
Okay.
I'm going to give it to you and you're going to have it forever. All right? For free.
All right.
All right?
All right. Thank you.
Yeah. No problem.
Yeah, so that was honestly all of my questions. The one thing I do want to just say this, when you said this on Tyler's video, it kind of opened my mind a little bit
I'll say
and
it again.
got me thinking, like, where are they? So you said, what if the people that control, and this is when you were looking at the map, and you said, what if the people that control us are out like side of it or outside of the flat earth or something? And I was like, huh, that is honestly a really interesting perspective.
Right. So large bodies of water at rest need containment. But here's the thing. A lot of people get really upset when we speculate about things that we don't know. We don't know what's beyond Antarctica. We want the right to go explore. All of our history is a lie. And in Pennsylvania, there's amazing old world buildings that we didn't build, that a previous civilization built. They're right in front of you everywhere. They're everywhere. Yeah. Okay. So, you know, is this the way the world looks, right? And all of this is Antarctica? You know, they tell us if Antarctica melts, the oceans are going to rise and we're all going to be underwater. I'm like, how does that little island, 13,000 miles around, going to make an effect over the giant Earth? Well, if this was Antarctica and all of this snow melted, okay, hey, maybe it would raise this pond up higher, okay? So, interesting. So, what's out here in the outer space? We don't know, right? I like to speculate. There's some great books. One of them's called The Iron Republic, about a politician out of New York in the 1800s that got fed up, sold his house, sold everything, bought a nice big ship, got a crew, went exploring Antarctica, and they got lost, right? They went through, they went into a canal, and then they popped out in the ocean again. The stars were all different. They couldn't figure out where they were. They were lost at sea for like 2 months or something, or maybe a month, or whatever it was. Maybe it was three months. And then they saw land. And they saw a city, and they pulled up, and a boat came out. And the guy spoke English, and he said, welcome. He's like, we're from the United States of America. Where are we? And he goes, well, you're at the Iron Republic. And they said, where's the Iron Republic? And they go, well, it's on the other side of Antarctica, about the same distance that the United States is. He didn't quite understand. They went in. Long story short, they ended up living there for 10 years. He got rid of his ship, traded it for, you know, whatever monetary system they had. And he got married. He found love. And then after 10 years, his wife died. Something happened. He got distraught, got his ship back, and made it back to Florida, where in 1901, he wrote a series of articles in Florida Magazine called The Iron Republic. and he said proof and everything. Now, whether it's true or not, in the 1800s, they were talking about more land beyond Antarctica. Interesting. Interesting. Right? What if the world was like this? What if we just have another continent out here inside of our ring, right? And GPS doesn't let us go there. NASA's in charge of GPS. I assume you know that NASA is complete and total garbage. Nobody's ever been to space.
Oh, definitely. I would agree with that wholeheartedly.
Okay. All right. So that's stuff that we can talk about, but we don't need that to prove the shape of the Earth. High pressure next to no pressure can't happen without a barrier. Water, physics of water laid level. Gravity is a theory, right? That's all you need. We can see too far. On a ball, there's a required physical limit that can't be surpassed. A 6 foot tall person standing at the edge of perfectly calm water on a perfectly clear day should not be able, standing up, should not be able to see the surface of the water beyond 3 miles because there's a 6 foot drop at 3 miles. 6 foot drop at 3 miles. Okay. Therefore, you shouldn't be able to see the surface of the water, but we can. We can see the surface of the water dozens of miles beyond that. That's impossible. It only works on a flat Earth. And if you sat down, the horizon's like less than 2 miles away. Okay. But we can see oil rigs 15, 20 miles away. We can see the water surface beyond them, right? We can see things so far away, it makes absolutely no sense. For example, here is a shot from, when you're down low, the air is the thickest, the dirtiest, hard to see, lots of miraging. But up at the top of a small mountain, the air is thinner and clearer. And we could see these mountains, all of them, they're over 700 miles away, all of these mountains. From this height, using one of the globe Earth curve calculators that gives the globe the benefit of the doubt compared to the other, right? It's the one that gives the least amount of curvature, says that the tops of these mountains should be over 40 miles below a physical curve, but we can see them all. You know what the mainstream media says about this one?
What?
Nothing. They won't even acknowledge its existence.
Because they're scared.
They're scared.
Probably.
Right. They're scared. And think about this. Can you tell me why would they lie about this? Can you tell me? Why would they lie about this?
I honestly don't. I don't know. Honestly, because they want control is the only reason that I think they just want control. But I don't have a better answer than that.
That's a great answer. That's a great answer. But there's a lot more to it. In times of tyranny, which we live in, what if you found out there was other continents, other places to go? That's one thing. They don't want you going there. They need you as their little tax slave. They need your energy. Second thing is, what if you knew that you are at the center of creation, that you're not from a random lightning strike, out of nothingness and evolved from monkeys? What if you found out that you were created, this place was created for you, and you were placed here to have a relationship with the creator? That would kind of empower you. What if you found out that nobody can take your God-given rights away, right? What if you found out that there was free energy, that you can have all of the energy for free that you need to heat your house, cool your house, and drive your car? You would never have to pay for this.
Nikola Tesla proved that. So,
well, this is the Tesla coil. Whoop, come on. There we go. Well, if it's going to focus, let's see, focus. This is the Tesla coil that literally pulls energy out of the ether. Okay.
Literally.
It's amazing. Yeah. It uses 100 watts. It outputs thousands of watts. It's an amazing healing machine. Okay. They won't teach you about that in school. And
that's actually how I became not believing anything, honestly.
When you look into the old world and everything, it'll blow your mind what's being hidden from us. So they're hiding old technology, they're hiding free energy, they're hiding more land, I believe. They're hiding the fact that overpopulation is a myth. I think there was 100 billion people here in the 17 and 1800s. Okay, 100 billion.
I mean, Texas could fit most of America
You are
itself.
everybody could have a quarter or a half an acre in Texas, and the rest of the country would be empty. And I think it's every family gets an acre in Australia, and half of Australia would be empty. The entire world can fit in half of Australia. Okay, so
Yeah,
and I built garden. I lived in a little apartment years ago, and I built two 5x10 raised garden beds. I fed my whole neighborhood, like six houses. I fed everybody. Okay, I couldn't eat the amount of food that was coming out of there. So to say there's a food shortage, to say there's an energy shortage, right? They want you feeling insignificant. They want to hide the fact that you're at the center of creation. They want to hide free energy technology. They want to hide the fact that overpopulation's a myth, right? They want to hide a lot of things. On the app, if you go to the homeschool button, there's some amazing stuff, old world stuff. This guy, amazing. Looks at old buildings, reads you what the story is behind it. It literally, you'll die laughing. Okay. Over here, this guy looking at old world stuff. His name's I'm the Improbable Dreamer on TikTok. He's amazing. This right here is Crow 777 Radio, CRROW 777 radio.com. This is a podcast that comes out twice a week, and there's 500 past episodes. If you listen to one episode each day of the week, take the weekend off if you want, you will become the most successful person in navigating this world's twisted reality. They teach you everything about what's going on, about our history, about taxation, about natural healing, everything, right? I tell people, don't send your kids to college. Send them to Crow University. It's $8 a month. Okay. This is better than any education, and it won't put you in debt, and it won't indoctrinate you. Okay.
well,
This is somebody, if you listen to that podcast, for a year or even less, I'd probably hire you. Okay. I would want to, that's the kind of people that I want to work with, people that are learning this information, all of this information. Right? You want to really
yeah.
go dive deep on some flat earth topics right here, Schooling Globers. All right. Great series. Great series.
Okay.
Yeah. So amazing. Amazing.
All right. Thank you for like taking the time and answering like the questions. That was honestly phenomenal. I took some notes. That was awesome. I am honestly kind of mind blown a little bit, but
Listen, here's the thing. Be careful. Don't go running to tell people the earth is flat until you know. When you wanted to, you're gonna be dying to talk to somebody about it. And so what you can do is just ask, make sure you pose it as a question. Like, hey, the earth is curved. How come we can see, 20 miles? Well, 10 miles, there should be 66 feet of curvature. How come I can zoom in across this waterway and see that beach? There should be 66 feet of curvature. It should be hidden, right? You just ask questions like that, or on the app. This is a good one. This is great. So you click the web button, which is the more resources button. You scroll down right here. It says full length videos, right? And if you go to the full length videos, and where is it? This one right here, Flat Earth 21 Questions, A Stranger's Guide to Flat Earth 21 Questions. It's the top 21 questions, all in 3 to 5 minute format. And say, watch it with a friend. Go, hey, this guy. Oops, hold on. This guy is offering 3 Bitcoins for 1 globe proof. Can you help me? Like, let's watch these 21 proofs that they have and see if we can debunk them. And you can't. You can't. And then it'll plant seeds. And then now you're creating new awake and aware friends. But another thing on the app, which you'll like, because you're going to be, you might not have many people to talk about, is if you hit the little handshake button. This is the friend finder, right? So let it load for a second, and it's going to show you the other people that have the app near you, right? And then you can actually look at their profile. You can send them a message. You can do voice or video call. You can join groups. There might be a group called Pennsylvania Flat Earth or something on there, right? Give it a second. There's a lot of dots here, and I just installed this. So there we go. Look at this. These are people around me. I can click on a dot and I could look at the person's profile if they filled it out yet. Here's buddy, and then you can go to you can message them. You can say all sorts of stuff. Like if I hit that one, let's see what happens. And here's CC. I know, Chris. This is CC. And information. You can send messages, all sorts of stuff. Right? I'm going to actually add him as a friend. Boom. Okay. So now he's on my friends list. And there's all sorts of fun stuff you can do on there. All right.
Okay. Yeah.
All right. So I'm gonna email you a code. You're gonna go to the Google Play Store, and when it's at checkout, it says enter token or code. Cut and paste that token in there, and you can download it for free. All right.
Okay.
Then after you download it and you go in and you accept the permissions, it needs permission to use your location. You could say no, but then you can't use a friend finder. Just so you know, the location thing obscures your location by 5 miles unless you tell it to go exact. All right. So your phone's already tracking you. This obscures your location. I could argue that this actually screws up if anyone's tracking you. And then after that's all set up, excuse me, click this button right here, the gear button.
Mm-hmm.
You're going to scroll down to the very bottom and you're going to apply a code that I'm going to give you right here. All right.
Okay.
And that's going to unlock all of the locked features.
Okay.
Right?
All right. Thanks, man. It was great talking to you.
All right. So, oh yeah, last thing. Every day there's a featured video right here. Watch that video. Watch the videos that come after it if you want. Archive videos. You can go back 5 years and watch those videos. Frequently asked questions. Watch those videos. And just keep watching, keep learning until you feel confident enough to talk to other people about it. Right? Because people are very indoctrinated, so much to the point where they refuse to even look at flat Earth. Right? They refuse to look at it. So it's going to break soon. There's so many people waking up to flat Earth. It's gonna, some big podcasts are coming out. They're gonna be talking about it. And you're coming in
This
right at the right
great
time.
awakening.
What's that?
This is the great awakening.
You got it. You know your stuff. But I encourage you to listen to Crow 777. It'll be a great podcast for you.
Mm-hmm.
And then
All
there's
right.
tons of other free stuff on there. You don't even have to pay for it. All right.
All right. Thanks, man.
All right. See ya. Thanks.